For people with hearing loss, finding a solution allows them to reconnect with their loved ones and the world around them. While a regular hearing aid makes sound louder, for some people with conditions that block the hearing pathway, it can be difficult for amplified sound to reach the inner ear. This is where a bone conduction system can help, as it sends vibrations directly to the inner ear. Let's take a look at how a bone conduction system works, using the Cochlear Osia System as an example. The Osia System features a small sound processor placed off the ear, leaving the ear canal open and free from occlusion. It also features an active internal implant that is fused to the bone and sits underneath the skin, with the sound processor attaching via a magnetic connection. The implant contains the unique piezo power transducer, which converts sound to vibrations. It is placed at the optimal distance from the processor microphones to reduce feedback. This unique design helps ensure a clear signal, free from unwanted feedback noise. Now let's take a closer look at how the key stages of the signal processing pathway work in the Osia system, starting with the first stage, input. The sound processor can receive input through its 2 microphones and via streaming from a user's personal accessory, such as a smartphone. The processor's dual microphones contribute to processing directionality, which can help patients focus on conversations in noisy environments. During the first stage of the pathway, where the signal is received, converted into a digital signal and then analysed, different directionality patterns can be applied. Omnidirectional. For a broad all-around sound that mimics the outer ear for a person hearing naturally. Fixed, which captures sound mostly from the front and reduces sound from behind the listener in a fixed direction, very useful for noisy environments like a cafe. And auto, which is our default option. Auto captures sound from in front, but adaptively tracks and reduces moving noise sources around the listener when speech in noise is detected. Like many hearing devices, the Osia sound processor has a scene classifier, which actively scans the user's sound environments, accurately classifying them into 7 acoustic scenes. It then automatically applies the best directionality pattern and loudness to match the appropriate situation, so recipients can hear their best without needing to make manual adjustments. In the next stage of the pathway, gain control, the broadband signal is transformed into 17 individual frequency bands. Then the overall signal is adjusted for audibility and comfort, using input from the scene classifier to deliver a clear signal. Unlike previous technology, where gain is based solely on the input level, active gain takes the environment into account, automatically adjusting the amplification level to match the patient's needs across different listening situations. With hearing in noise often cited as one of the biggest challenges for users, noise reduction uses a 4-step approach to analyse, identify, clean and amplify the speech signal, helping our users engage in conversations. Wind noise reduction in the outdoor program is designed to reduce the experience of wind noise while maintaining speech signals. It measures, monitors and stores average sound input levels so that when wind is detected by the microphones on the sound processor, gain is reduced to the appropriate levels in order to maintain audibility and comfort. Whilst the input signal is being analysed and processed, the feedback manager works as a returning loop that monitors the input to the microphones and output to the implant. It identifies what important sounds should be amplified and what sounds should be disregarded as feedback noise, thereby optimizing the sound signal we want to preserve to create the best listening experience for the user. In the last stage of the signal pathway, output, the data and power from the processor are sent via a digital link through the skin to the implant. The piezo power transducer then converts the signal into imperceptible sound vibrations by expanding and contracting the material inside. These vibrations travel through the bone, where they are picked up by the inner ear and then sent to the brain to be interpreted as sound. When a recipient first receives their sound processor and during ongoing appointments, the fitting software is used to make adjustments that optimize audibility, comfort, and sound quality, improving a patient's overall hearing experience. At Cochlear, we're proud of our track record in delivering innovative implantable hearing solutions, giving you more ways to empower your patients to connect with others and live a full life.